Saya present English or BM?
Preferably English so that korang biasalah present English nanti korang nak interview ke apa ke most probably in English kan. So practice your English.
Okay, sir. Okay.
You
Bismillah.
can see your slide.
Yes.
Yeah. Please proceed.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Saya Lukman Hakim bin Ashraf Rauf and my partner Muhammad Akil bin Kamaruddin. We present about our mini project which is temperature control.
Okay, for introduction, objective of the project. First, to detect the temperature of surrounding environment. Second, to develop to GUI for measuring element system. Okay, go to the background research. Okay, first we are target in country Malaysia only that can be used. Malaysia expensive hot and rain wetting throughout the years. The second, the average daily temperature throughout Malaysia is between 21 darjah Celsius to 32 darjah Celsius.
Saya interrupt sekejap. Tak apa, it's okay that bukan kalah mati pun kalau korang punya English tu tak bagus. It's okay, just that I'm commenting so that you can improve. 21 degree Celsius throughout, and then the first words tu I would insist that you guys make it better by we are focusing and limiting our studies only for Malaysia. Tu je. Tak perlu sebab if you're using we are targeting in country Malaysia only that can be used. It's actually very wrong. It's kind of confusing. So just put we limit our studies or we limit our work to Malaysia. And then average daily temperature throughout Malaysia is between 21 degrees Celsius to I'm not sure 32 degrees Celsius is right or not, but if I'm not mistaken, it should be higher than that because there was a time when when I was riding across Shalam, the temperature stated there 34 degrees Celsius. So double check on your 32 degrees Celsius. Okay, please proceed next.
Okay, the third engineer will need. This is the background or research on the use ethical engineering of solve your problem. Okay, engineering will often use reverse technique to solve problem. For example, by differentiation or something to determine a problem, finding a way out and putting the object back. Engineering know how to something work, and therefore they constantly analyze something and find out how it works. For example, in our project, we study the current ambient temperature condition in Malaysia to be programmed in our project that is temperature control. As an engineer, we identify the appropriate temperature to use in order to provide comfort to use.
Okay, one more comment, sorry. What you're trying to do is actually, for me, it's good. I mean, you just list out the summary on your slide, and then you have a different report or something that you read from. Actually, it's good, but try not to make it too obvious that you're copying from some other's work, because I can see from your slide here, your English is literally not that good, lah. Whereby in your when you read your report, I can see that the English is very good. So it's too obvious. This is just a tip, nothing got to do with your marks, but this is just a tip for your FYP presentation, for your future interview. Just don't make it too obvious. what if I were in your position, what I would do is I'll just take the first three sentences. That's it, to elaborate on your slide. And I don't read the whole. Engineers will often use reverse technique to solve problem and sampai comfort to users. I won't use that. I'll just use
Okay.
reverse technique example, and then engineers know how something works. That's it.
Oh, okay, sir.
Okay. All right. Next.
Okay.
Next.
Okay, next we go to the methodology, which is block diagram of our project. We use the temperature slide as our input, and which we connect to the numeric indicator that we change the name to the temperature. And next we connected to the comparison block, which is greater or less, that has its constant, which is 30 and 23. And next we connect both to the comparison block again, which is select block, and that has the constant 1 and 2. Constant 1 and 2 because constant 1 is selected if temperature is above 30, and constant 2 is selected if temperature is below 23. And next we connect to the um, I forgot the name of that square.
Summing block.
Summing block, which is that have three condition. We normal, high and low, and we put all the component in the while loop to run our simulation until the condition is met.
Okay, can I ask one thing? Between greater than block and then the summing block, there's I'm not quite sure what symbol is that. I haven't had a chance to use that. What is that block?
Uh,
How does it work? The comparative block?
um,
Because I
we
understand 30 1 will give out 1, but there's a 0 down there. So what does it do?
zero, else zero is selected.
Oh, so if it not turn on, then it will give 0.
Yes,
If it's turned on, if it's true, then it will give 1. If it's and for the 23, if it's true, it will give 2. Am I right?
yes, sir.
So that means your while block, you have 0 default, and then 1 case the for the high temperature, and then 2 for case
Low.
low temperature. Okay, understand. All right.
Yes.
And why is the LED on top of there is not connected to anything? What's the purpose of it?
Because it's our output, and the our output is connected to the um in this case structure.
Okay, can I okay, can we look at the front diagram? Uh, oh, so the LED is the indicator, is it?
Yes, yes.
So it's not connected to anything?
No.
That's my question because okay, can you go to the front panel?
From panel, that's in the simulation.
Oh, it's okay. Oh, simulation. Okay.
Simulation.
Okay, then we'll proceed with your slide first, and then we'll go to the simulation.
Okay, next.
Okay. What is this sensor use? First, we use temperature sensor to control the temperature somewhere. We know that Malaysia, there are only two climate which are sumo and rain. The second, a temperature sensor is a device for a machine measure temperature reading and view electrical signal. Okay, next to how does the sensor do its measure? Sorry. Temperature sensor detect when the temperature is high, normal, and low. Second, we use three color, which is red for high, green for normal, and yellow for low. Okay, for other example of sensor can be used as well, although not being used in our proposal is humidity sensor. Um, this sensor work to detect change in temperature in the surrounding air. Uh, this second, this sensor work to detect. Sorry. Uh, this sensor is the same concept as the temperature sensor. That is, the it is detect temperature reading through electrical signal. Okay, next.
Next, to the graphical user interface, which is GUI. We use this temperature slide. No, sorry. For our simulation, we use temperature slide as our GUI. We use this temperature slide because it can control the temperature as we wish. And the temperature slide is connected to the numeric indicator. Okay, next. Okay, for the result, this is for result for the low temperature. When the low temperature, the LED will turn to yellow. And we go to the block diagram. Next. Oh, no block. Okay, next we go to the normal, which is when the temperature reach the 25, the LED will turn green, which it means it's the normal temperature. And next for the high temperature, when the temperature is above 30, the LED will turn red and it show the high temperature. Okay, next.
Okay. Can you? I just thought you have
Back.
another slide. Okay. For this one, I don't actually agree with you using the LED meter here because it indicates something like for normal there, I could change the value or something because the first time I'm looking at this, I thought the LED that you put down there, the LED that you didn't connect to anything, is it, I understand now that your LED here is to just indicate the color of low, high, or normal operation, right?
Yes.
Yes.
So when it has some sort of like what you call that, a scale on the side and at the bottom, I thought this was something that I could change if I were in front of the front panel. So I don't agree with you guys using this. If possible, I think you can just use the LED there. Can you go the same LED that you use for your while block diagram? So that same LED, instead of you connect it to the while condition, you can just put it outside, substitute that with the LED that you're using right now, and just change the color rather than like this. Because if you have scale like this, like I said, it seems like I can do something to it. When the intention was, what you guys were trying to do is just to indicate the color of the operation. So yeah, that's just some minor comment lah, nothing much. Just that for you to, if possible, if let's say one day you have to do the same project, just use the same LED that you use up there, but instead of connecting it to the while diagram, change it to the color that you want to use show.
Okay.
Okay, sir.
Okay, next, last one, discussion.
Question. Okay, for our discussion, with the temperature control, we can control and detect the temperature around us and also can provide comfort to others. And next, we identify some component used to be suitable for the use of sensor. We use the temperature sensor as our input to detect the ambient temperature, and signal to the output is that LED. Okay, next.
Okay, for the For the last one is conclusion. Temperature control is major problem is of fast growing world and require cost effective solution. Um, and next, this temperature control can use in various industries such as mall, office, indoor theme park, and others. Um, our advantage is that we can identify the ambient temperature and can control it better so that the surrounding conditions are not too hot or cool. And this when disadvantage is that this project can only be used in Malaysia only because the set temperatures has been programmed according to the current climate in Malaysia only. Uh,
Okay. Thanks. Thank you for your presentation, for your work. But some extra comment that I think quite major. Okay, first, the title is temperature control. Even in your conclusion, also you've mentioned that this is actually a temperature control project. But in fact, if you're looking at the output, this is just temperature indicator. There's no control here. What is
oh,
being controlled is actually your temperature slider here. So that means most probably if you set it in a room or in an area, it's the temperature it reacts to the temperature. It's not going to change the temperature of the room. It's not going to change the temperature of the surrounding. It's just indicate whether is a normal operating temperature, it is high operating temperature or low operating temperature. There's no control here. So that's a major problem with your proposal, which means the title, temperature control. This is actually temperature indicator.
indicator.
Okay. And then your objective actually reflects the temperature indicator, not temperature control. Your objective is correct provided your title change to temperature indicator. Okay,
Okay, sir.
and then that LED lah. I think that LED is quite major for me because it confuses me, and I believe if it able to confuse me, the same will goes to everybody else who haven't had the chance to view your project lah. So I mean to listen to your presentation. So when the first time they look at the front panel here, chances are they will be confused because what's the button normal, high and low here? What does it use for? So for me that is quite problematic lah, that you need to address. But for your mini project work based on your rubric, uh, introduction okay, results I would have to tune a bit, discussion okay lah, conclusion I have to say it's not accurate because your conclusion here says temperature control when it is just temperature indicator. So yeah, it's not actually Nila. But I'm just being frank with you. But if you want to improve, you want to if you want to make sure that you get a good mark, just resend to me a video of your lab view simulation to show what improvement that you have done. And of course the title have to reflect lah. If I address you, your topic is because your problem is because your title and you addressed it, make sure you mention the topic there at at the front panel. Just type in text there, or if possible lah, if you know how. But if not, then the file name, just the file name of the video should be okay.
Okay, sir.
All right. Thank you. Thank you for your time. Thank you, Muhammad. Sorry.
So we need to show our simulation.
Yeah, please. I just want to make sure that it works.
Okay. This is our from panel.
Mm-hmm.
This is for our block diagram.
Which is similar to your report. So it's okay, it's good. So now just run the front panel simulation.
Okay, for the low temperature, the LED we go to the yellow.
Mm-hmm.
For the normal temperature, the LED we go to green, and for the height we go to the red.
Okay, anything above 30 is high, anything above 23 is medium. All right. Okay, good. So it shows that you did your work as per intended. So yeah, it's good. It's just that some minor correction, I think, which you actually did not reflect your work on the topic and also on the conclusion.
So we
Uh,
need to resubmit our report.
Not the report, just the simulation, the video of the simulation showing the change that you've made. So, if possible, try to add temperature instead of temperature control. Put the title on top of the block diagram, the front diagram, front panel here that says temperature indicator.
Just put the title temperature indicator here.
Yeah.
Okay, sir.
All right. Thank you, Luqman Hakim and Muhammad Akil.
Okay, thank you, sir.
You're welcome. Next, I would like to ask. Okay, for the rest of the. Hold on, eh. There's another. Okay, group Zuhaikal and Nick Adli. Can you guys start your presentation? There are a few questions I would like to ask.
Sure, Doctor. Okay. Assalamualaikum warahmatullahi wabarakatuh. Okay. So
Salam.
today I want to present water level alarm. Okay. So our group consists of two members. Okay. So my name is Muhammad Ali bin Abdullah, and my partner is Zaika Rizin bin Zamrud. Okay. So for the contents, we have introduction, methodology, result, and discussion, and conclusion.
Okay, so we go to the first one, which is introduction to the mini project. Next. Okay, so we will let you know our objective. So for the first one, our objective is to learn the working of a water indicator. The second is to avert and control the water level. And the lastly is to produce a sound with the help of buzzer when a water level in the tank reaches is predetermined level. Okay, that's our objective. Next. Okay, so we go to the background research. Okay, so it may be tough to accept that the water crisis has reached a point of no return because of excessive water waste owing to overflow in the above tanks. A water level alarm can give a solution to this problem by preventing it from becoming waste. And this water level alarm employs a simple mechanism to detect and indicate the water level in an overhead water tank or any other water container. And for this project, a vertical point is used to control the level of the water in the tank, and upper level indicator will be shown when the tank is about to completely fill. So that is our background research. We go to the number two, which is methodology. So like you all can see, this is our block diagram and let view. Uh, okay. Next. Okay, so what is suitable sensor use and why we use it and how its measurement. Okay, so the first one is water level sensor or detector. Why we use this? Because to gauge and manage the water levels in a water tank. So how does the detector can be measured? It does measurement by using sensor probe to indicate the water levels in a water tank. And beside beside we using this sensor, we can use the other sensor, like example liquid level sensor, because its function is quite same like the water sensor or detector, because the function of the liquid uh, used to monitor and regulate level of a particular free flow substance within a contained space. That is a function of liquid sensor. So uh, that's for our method.
Okay, so next for graphical user interface or GUI, we use first we use which is to delay the flow rates of water. Second, we use in range and cost. Its function is to only operate in the setup of range. Okay, next, greater or equal and less or equal. Uh, it is for condition needs to operate. Next, add and subtract. It is a mathematical calculation for the project. Next, bit.vi. It acts as alarm. Next, we use round LED. It is to notify the condition when it meets. Next, we use stop button. Its function is to stop the simulation. After that, we use tank and gauge. It is to display the current water level. And lastly, we use vertical fill slide. It is to adjust the flow rates of water. Okay,
Okay. Sorry. Can I interrupt for a bit?
okay.
Which one did you use for the feedback of the some ad block ad block? What do you call that? The additional the ad block, the feedback. Can you go to the block diagram? There. The yellow arrow going back to the feedback to the block additional adding block diagram. Which block is that?
It's actually when we connect the right uh
The first input back to the output to back to the first input. It just shows
yes,
like that.
and it's automatically appear that diagram.
Okay,
That's the name.
and then what is the 100 and 0? I'm not sure what
In
block is that.
range. It's in range for us.
Range block.
In range,
Yes.
meaning it. What does it do?
Its function it will function when our scale is at 0 to 100.
Or it just limit
Yes.
the operation from 0 to 100 only.
Yes.
And why do you need that?
Because at first when we do our simulation, we don't use that's component, but our simulation do not uh stimulate like what we expected. So after we do some research, uh some of them use this component. So we try and it's give positive feedback for us.
But the range that you put for your flow in and your flow out is actually, or maybe that is because there's a possibility your flow out is bigger than flow in, so it give negative value. And when it comes to negative value, it goes to the summing block, and then negative should be positive, but the range will be negative for. Okay, when you said that it doesn't work when you don't include the range block there, what happened? Whether the when you click run, does it totally not responding, or there's some sort of output, but you cannot comprehend what's the output for?
Actually, when we don't use the in range for us,
Mm.
it's crash our simulation.
I think it's because of the negative value, but flow in and flow out, what is the range that you set there for flow in and flow out? 0 to 10, 0 to 10.
Uh, Actually, this just in the block diagram, but in the uh, in
Simulation.
when the simulation is on, the flow in we can adjust from 0 to 10. The flow rate is per second.
10 liter per second. So if we go to flow in, it will uh,
Show 10
show
liter
the
per second.
10 liter. Yes, 10 liter, 10 liter, 10 liter.
Okay. Maybe I myself haven't had a chance to do my own water level based on your range here, but I would think the issue is with the negative value. But since you put there 0 to 100, the range diagram there, so yeah, I think okay, good. It shows how you troubleshoot. That means you don't just sit there and then ask me around and to solve it. I mean, you did your own research into it, but you for me lah, if I were an engineer, most probably yeah, but the same way that you did. But if I were a researcher or at least a manager level post, I need to come up with why the system need to use that, because in real life, most probably it will introduce a cost into the budget, which most probably will be extended. So if it's cheap, then it's okay. But chances are, if it requires a specific block diagram that is quite pricey, chances are you need to justify that to your board of directors or whatever. So yeah, but for engineers, I guess just proceed lah. Okay, next.
Okay, so next for expected result. As you can see on the left figure, we can see the empty tank condition, and on the right one is full tank condition. Okay, so doctor, can I stimulate our program?
Simulate, bukan stimulate.
Simulate.
Okay, please.
Okay, so now I'm going to
Okay, so there's a beep, eh? Okay, when you go low.
it will produce the sound of alarm. Okay, so now I will flow out the water from the tank, and the alarm will off. Okay, so when the water level is below the 50, the empty LED will lights up.
Okay, so that's why I didn't hear any beep because you didn't connect the alarm on the empty side of the connection. Okay, okay, good. So I think your project is quite interesting because I thought it was flow in and flow out, something else from something else, but apparently your flow out is actually how fast the flow out versus flowing in control in the water level. So yeah, I think it's a good job. But just to double check, Can you go back to the water level being full? I just want to hear whether the beep is. Okay, so the beep works. And this is a very good project, meaning it's not straightforward. It's the relationship between flow in and flow out, and you're using the flow to control the flow lah. So as you can see, if you recall previously, I've mentioned most studies, if you want to control a process, most study would prefer to use direct relationship between the output and input. So for example, temperature, you turn on the knob, temperature will rise slowly and then will reach the settling point that you set almost immediately. Whereby for flow and pressure, as you can see here, when the team member increase the flow in, it will take some time before the water level reaches the full what you call that, the full limit. And then if he or she increase the flow out, it will also take some time before it's being empty. So it's not directly controlled, meaning you have to wait for quite some time before each of the limit is being satisfied. So the same with this case are being shown. So if you turn off, so typically like when you use to do your mini project, when you turn off a circuit, it will immediately be turned off. You turn on the light, immediately turn off. But for this flow, pressure, and from flow and pressure lah basically, if you turn off the system, as you can see, that's what's happened with with the nuclear in Russia, the nuclear reactor blowout.
Chernobyl.
Chernobyl, the same like this. They turn off everything. They have turned off all the full maximum flow of the cooling liquid and turn off the system and whatever, but still it blows because it's not directly controlled like the way we control our switches. So that's why it's very hard for this kind of system. But for me, it's a good, interesting case project that you tried to show, which because you're using flow. So yeah, it's a good point for you. And my question was previously, what happens when the water level is at normal? So as I can see here, it shows both are being green lighted, meaning that there's no problem. So okay, good job. Okay, next.
Doctor,
Yeah,
I think if you want the flow in to go faster, we can change at time limit, time delay.
time
We
delay
have a delay, so we can see the water
immediately.
is flowing in.
Yeah,
So
but
if we want it's to go fast, we can just
Adjust the
remove
yeah.
we can just adjust this thing.
Okay, so what you have done is actually a more real case scenario lah by introducing the delay. So for me, it's a good job. All my yeah, for me, it's a good job that you have been using the delay compared to just simply flow in, flow out, and then control directly like our lab. So you've taken the extra step further. So it's good thing, good job, kudos. Okay, next, please proceed with the presentation.
Okay, so next for our discussion. Okay, first when we work on this project, we know that every connection in the block diagram is very important. Because when we doing the mid projects, we found that uh, when we wrongly connect the connection, the final result is not as what we expected. Next, we also noticed that the buzzer and LED played a big role for this program because with both of them, we can know whether the simulation is working or not. Next, we face a problem when using LabVIEW where the application crash when we run the program. This is like what I'm just said before. When we run the program, it's crashed because I don't know whether it's because of some component or it's because of my lab view, but that's what's happened when we are doing the mini project. Okay, so last one is for the conclusion. So for conclusion, from this mini project, we can conclude that LabVIEW is a very good platform that students can use to make their project. From our mini project, we learned how the water level indicator operates. This project also has a lot of benefits such as to avert users from any risk of water leakage by ringing the alarm when the water tank is almost fully filled. It also has disadvantage, which is the water level control will rust and need to be replaced with a new one every 3 years. But the market price for the water level control right now is only about RM 70 to RM 90. So it is still affordable due to the effectiveness of the sensor. This project can be applied at home because its scale is only up to 100 liter. So that's all from us. Thank
Okay.
you.
Again, there's some confusion with the topics. You guys are not using water level. You guys actually control the flow in and flow out? I mean, of course, in the front panel you can adjust the flow in and also the flow out. But in real system, when you imagine this being applied at the home, for example, can you actually adjust flow in? Because right now in our house, all the I mean you can actually go out to the front of your house and adjust the what you call that, the pilih air tu daripada syabas tu, and make it flow in greater, but I don't think it's not going to be 0 to 10 lah. Most probably most people will just close and then make it full open by maximizing the pilih punya turns. And flow out is how much you're using. Of course you can control that, but this project is what I am seeing is more like indicator. So can you justify your topics that you choose as water level control? In what way did you see it is being controlled, the water level? Even your objective here mention water indicator, but there's a avert and control the water level. So in how do you see it? Okay, if you can't understand what I'm trying to ask you, imagine you in let's say for example in a what do you call that, in an industry lah, making water for example. You can typically what people would do is flow in is from the Shabas water line, so they'll either 0 or 100 turns. Jarang nak ada orang buka tengah-tengah. And then flow out is how much you're using. I mean per day, how much water that you're using to boil water and whatnot to consume. So in what way does this project, if let's say everything else being substituted by this project, in what way it's being controlled, the water level? Does it automatically fill up the flow in when it's empty? Does it automatically adjust the flow out when it's full?
It's did not automatically off or on the uh, flow in or flow out of the water.
Uh,
It will just ring the alarm and turn on the LED.
so I would suggest you change your objective on the number 2 to avert and control the water level. Either remove it or reword it so that it reflects water indicator or water level alarm system, for example. So that's just one minor correction there that you need to make sure. Make sure being adopted in your studies. Just change the title lah. At the moment, right now, your simulation shows water level alarm is actually good, but your mini project report here mentioned this is a water level control, which, based on your work, does not reflect your work, actual work being done. So, yeah. And even your conclusion here, you mentioned water level control, which of course 70 and 90. So because it controls most probably, but I don't understand because your project here is more towards indicator and alarm system, for example. So it might be more prudent for you to change it, to change the conclusion and the title. But uh, I guess in your case, your simulation is everything is good, but the mini project report. For me to give your marks, if let's say there's an audit coming in, checking my work, I need to show that uh, what I'm giving you, the marks that I'm giving you reflects your work. So I need to have the work that says this is but I guess that will be the same with group Akil and Hakim lah. Right.
Yes.
So I guess you guys have to resubmit your mini project report. Yeah, but it's nothing much. Just change the word so that I have a proof that I'm giving you marks for the work that you have done. If there is an audit, I'm not saying every semester will have auditor coming in, but if there is an audit, especially for those for your ETEC, for your accreditation, they will have a few panel from the industry coming in and checking and will be checking our works. So they will look into this. So this is an example that I need to show. If let's say my luck has run out and I have to show them my work. So I guess you guys have to just to have to resubmit your mini project report to show that this is not water level control, and also for group Akil, this is not temperature control. This is temperature indicator or maybe alarm system and also water level alarm system. There's no control here.
All right. Thank you, Doctor.
All right. Sorry group Akil tadi. Ingat nak bagi simulation dia, tapi betul juga bila dia nak marking nanti kalau ada audit dia nak tengok juga report ni. So just change the title and all the mention yang previously mentioned lah.
Okay, sir.
Alright. Okay, next I would like to ask Mr. Afiq Aiman and Ahmad Haikal to present their water heating system with temperature detector and LED signal. For me, this is a good job because all the topic, all the detail discussed here is very good. Even the report is very comprehensive. So yeah, please, Mr.
Okay, sir. Yeah.
Ahmad Haikal and Afiq Aiman.
Okay. Assalamualaikum warahmatullahi wabarakatuh. So, my name is Ahmad Haikal bin Ahmad Fakaruddin, and my partner is Muhammad Afiq Aiman bin Ahmad Zulkifli, and today we are going to present about our mini project that entitled Water Heating System with Temperature Detector and LED Signal. So first of all, I want to tell you guys about our introduction. So our objective of this project is to make a system that provide a heating element for water. So the heating element for water is to basically to kill bacteria in water and provide hot and clean water to users. So next is to create a system that detect water temperature. Next is to make the system automatically turn off when it reaches the desired water temperature. And the last objective of our project is to design the most accurate temperature sensing system for water heating.
Okay, so for the methodology, the figure 2.1, which is the broad diagram of process control. which is consists of the measured temperature, controller, control signal, which is fan, the actual process temperature, and we use the flexiglass forks, and the outside temperature, and the process, which is the heat loss. And for the measurement is we use the thermistor. So next slide. So as the measurement, for the sensor that we use, which is thermistor, thermistor represent to the another class of the temperature sensor that used to measure temperature, which is true on the change of material resistance. Thermistor is constructed by a semiconductor material, which is the electron in semiconductor material are bound to each molecule with sufficient strength. So if no conduction electron are contribute from the valence bond to the conduction band. So for the water heating element, we use the NTC thermistor, which is when the temperature is increases, uh, the resistance will decrease accordingly to the temperature. So when the temperature of the material is increased, the molecule begins to vibrate and provide additional energy to the electron valence. So next. So for the another sensor that can be used and we do not use to in this mini project, which is RTD temperature detect resistor temperature detector, which is RTD. For the RTD is also the temperature sensor that based on the metal resistance increasing with temperature concept. So the method employed in the case devices range from platinum, which is highly repeatable, sensitive, and costly. For example, it is the method that is less repeatable, more sensitive, and less expensive. So next, which is for the signal conditioning. So there is three type of signal conditioning that we can be used. For the first thing is current excitation. The first one, which is current excitation, it is because the thermistor is a resistive device. So the data equation system will need to provide a current source to measure the voltage across it. So the current source must be exact and constant. The second one is the bridge. We mostly use the bridge circuit to do the signal conditioning, which is, as we know, the thermistor is the non-linear characteristic, so it's challenging to utilize an actual measurement device. So we use the bridge to do the signal conditioning for for this thermistor. So and the last one, which is linearization. So linearization is defined as the use of the additional circuitry to produce a voltage that has a more linear temperature function. Uh, Linearization is considered essential when working with analog circuit. So we use linearization for the only for the analog circuit. So the nonlinear conversion of ADC count to the temperature can be handled in number of ways. So next, 2.3, which is a graphical user interface. So the figure show the block diagram window in lab view. So the first thing is we use the horizontal horizontal point slide, which is we name here as the boiler temperature sensor, and we use the numeric indicator and we name it as a temperature, which is it will display the accurate value, which is including the point number. So we also use the meter to indicate the value of temperature, which is depending to the slide that we click on the horizontal point slide. So next we use the three round LED, which is we use three condition, which is for the high temperature, moderate temperature, and low temperature. So the first one is for the high temperature. We use the comparison block, which is we use the greater or equal, and the value we set up is start from 80. So if the value we click on the horizontal point slide is equal to 80 or more than the value, the LED of high temperature will be turned on, and the color we set up is the red color. So for the second one, if the which is for the moderate temperature. So we use two comparison block, which is greater or equal and less or equal. And the value is that the range of value, which is starting from the 30 until 79. So we use the logic gate, which is AND gate, to combine these two comparison block. And as we know, if we click on the horizontal point slide within the range of 13 until 79's value, so the round LED we turn on the moderate temperature, and we set up is with the green color. So and the last one for the low temperature, uh, we use the less or equal comparison block, and the value which is start from 29 and above. So as your as we know, the thermistor we use is the value range, as I refer to the datasheet, which is it can be used for the temperature sensing from the value of negative 20 degrees Celsius until 100 and 110 degrees Celsius. So it is because we set the horizontal point slide starting from the negative 20 value until the 110. So if the value we click on the horizontal point slide less than or equal than 29, the round LED will turn on, and we set up the LED for the low temperature, which is the blue color. So next.
Okay. So for the result and discussion, on the left figure is the complete circuit that we made. So sorry, the circuit is quite messy, but it's work. So as my partner said, the detail of the circuit in the block diagram, it has a vertical point slide, meter, digital number, and also contain three LED. So the whole thing in the block diagram, I put in a while loop, and also I put it in stop button and connect it to the while loop. So this is because while loop is the main usage of the while loop is to continuously run the program. So if we want to terminate the program, we can push the stop button. So on the right figure, it shows that the vertical pointer slide is at above 75, which is the exact value of the temperature is 90. So as we know, if the temperature is above 80, the LED will light up and the high symbol will light up. So for the moderate temperature, it is shown in the left figure. So at the vertical point slide, it shows that it is the temperature is above 50 and the exact number of temperature is 55. So as shown in the front panel, we can see that moderate temperature is the range of the moderate temperature is between 79 and 30 degrees Celsius. So the moderate temperature LED will light up and the moderate sign will light up also. So the last thing is the low temperature on the right figure, which is the slide is above 25 but below 50. So the exact temperature as we can see in the digital number is 28. So the LED with low sign will light up. This is because referring to the front panel, we set the low temperature range is 29 and below. This is because we use the less or less and
Less or equal.
and less, equal and less, sorry. Equal and less comparison block. Okay. So the conclusion of our project that is we managed to make a program that is able to heat up water and turn off automatically without any problem. So this project sharpened our skill in using the lab view because all of our program that we use in this project are using lab view. So this project can be applied in many places such as the water industry, cooking, and even at home. So this project is not too pricey to be exact, but the bigger the project is, the more expensive it gets because we need a bigger component to make the water heating element. So the bigger it gets, the pricier it gets. So that's all from us. Thank you.
Okay, thank you, Haikal and siapa tadi?
Afiq
Afiq.
Aiman.
Afiq Aiman. A good job. Even your presentation, there's no comment from me. So I think you guys did extra lah. For me, I think it's a good job. Not good lah, excellent job. So yeah, even your report here, you also included the references, which I think you've shown extraordinary enthusiasm. So
So
yeah.
do you want to see the simulation?
Yes, please. Sorry, forgot.
Okay. So we run this. So as we can see now, the load temp is light up right now because the boiler temperature sensor is below 29. And when we slide up, so now the temperature is above 30 and below 79. And we can see the moderate temperature LED is light up. And then Lastly, the high LED, high temperature LED is light up because now the vertical point slide is above 80, and then we can terminate the program and we can press stop. Okay, that's all.
Okay, thank you, Haikal. You guys did a very good job, so I'm very impressed with it. I guess that's should be the example lah. The effort that you did was exemplary, and thank you for your time. There's no comment from me other than it's a good job.
Okay, thank you, Dr.
Okay, welcome. Okay, next we'll move on to the last group, which is group Nur Fadil and Ahmad Fikri. Okay, for your group, I think it's also good, but again, the problem is with your title and notes. So before I make my own judgment, I would rather hear it from your side first, and therefore, please proceed with your presentation.
Okay, sir.
Okay, Assalamualaikum. Okay, my name is Ahmad Fikri bin Ahmad Asim and my partner is Muhammad Nur Fadil. Okay, today we want to explain about our mini project that is water level controller. Okay, for the introduction is water level indicator used to express the level of water in water tank. There have different water level indicator available in the market right now. Due to the lack of awareness of the abrupt increase of water in water tank, this can cause the wastage of water. We treat the water level indicator and controller to avoid the wastage of water continuously. Okay, and for the objective, uh, first is to avoid wastage of water. Second is to control the water in and water out. Third is save more energy and water. And then lastly is to generate the sound at buzzer to get workers' attention. Okay, next. Okay, for the background, okay, first is water level indicators works by using sensor probes. Okay. Second is the best sensor to use in water level indicator is stainless steel probe sensor. The stainless steel sensor prevents from rusting, fouling, and deteriorating due to poor water level quality. And then water level indicator usually sold as a two-part system, the control panel and water level probe. This is our block diagram. So first is desired level, and then go to controller, and then go to valve, to water tank, and then actual level. Then our sensor is stainless steel, a stainless probe sensor. That is our sensor. Okay.
Okay, for the graphical user interface, we use two conditions for indicating the water level, which are empty and full. We use a vertical pointer, horizontal pointer, water tank, numeric indicator, and two square boolean on our simulation. For when the water is full, we set the value more than 90 liters and the full boolean and buzzer will turn on. When the level is less than 5 liter, the empty boolean will turn on and the full boolean will turn off. Okay, for the result and discussion, as shown in figure above, when we run the program without the both vertical and horizontal pointer, the green light will on because the tank is empty. For the next figure is we can see the water slowly fill in the water tanks after we drag the vertical pointers. Okay, for the third figure shows that the red light will turn on after the water tank is full. Because the water flow in continuously and the water flow out is 0. Okay, for the next figure, we can see the water in water tank is slowly decrease after we drag the water fill up to 0 and water flow out is 10 and the red light will turn off. Okay, this is last. After all the water flow out from the tank, the green light will turn on again. Okay, for our conclusion, we are able to control the water in and flow out. Use water level control. We can save water to avoid it from overflow in the water tanks. It can get the using the alarm will install. It can get the user attention from the alarm when the water is full. Okay, that's all for us.
Okay, some comment. Again, the same problem with the previous two groups, which means you actually not controlling the because your program is not doing automatic control, right? It's just indicating. So you have to change the title. And also, if I'm not mistaken, or objective number 2 again to control the water in and out of the tank, which means yes, you can manually adjust, but if you put this onto your system, the on your in your house, you will not be able to control it because this is more like indicators only. Just set up the alarm and also provide whether it's full or empty. So the same thing with the previous group. Okay, and I'm not sure, but this is almost similar to the other group, which shows water flow. You have a feedback here, and you have the same, what you call this, the block diagram, range, 100, 0 to 100. So I hope you did it on yourself, but regardless, I just want to see the definition, which the problem definition is also similar, which shows that you cannot control, but more on, again, on the indicator. Okay, so can you show me your simulation?
Okay, okay, this is our prompt panel and this is our block diagram.
Okay, it's empty.
Okay, this is empty and it slowly fill in with the water.
Okay, because you're using a larger delay, so yeah, it fills up quite rather slowly compared to the other group. Okay, now it's full. So if you're saying this is a water level controller, what the system would do is after the red light shows that it's full, it will automatically increase the water flow out to let go of the to reduce the water level. So that's what is a water level controller. But what you're doing right now is more towards water level indicator because you have to manually move the water level flow out. Only then will the water level reduce back to middle or empty, right? Can you move the water level flow out? Why is it not moving?
Delay.
Okay, but delay 100 shouldn't be that long. Oh, okay, because you turn it on quite long. All right, all right. So for controller, you don't need to even touch the front panel after that. So if your indicator, you have to manually move the water flow out, move the water flow in to adjust to get to your desired level. So yeah, you're the same problem with the other group. But at the very least, your presentation, you changed it so that it makes it yours, such that it's much more cleaner and much more concise compared to the other group. So kudos for you on that. But again, since you have the same problem, I guess you have to resubmit your report lah for to prove that you have done the what do you call that, the correction and whatnot, so that I can give you the proper mark. Okay.
Okay, sir.
Okay, so that's it. I thank you guys, Fadil and Ahmad Fikri, and also the rest of the class for your
Thank you,
job
sir.
done, for your mini project. And please kalau boleh submit your mini project report tu dalam WhatsApp group pun cukup lah, tak payahlah nak Google Classroom, so that I can just record it, simpan dalam my own ni lah. Simulation tak payah lah sebab dah buat mini project ni, simulation tak payah, just buat correction dekat your mini project and then resubmit untuk proof bagi saya kalau ada audit apa-apa. Boleh
Boleh, sir.